DEI3093 ARINC transceiver demo board assembly with Raspberry Pi 3 hats, hardware attached on top. This is a DEI3093 ARINC transceiver in a quad flat pack package type device. The transceiver device is assembled on top of a DEI3093 demo board. The demo board is attached on top of a Raspberry Pi microcontroller board via 2x20 pin header connector.
This is an unattached Raspberry Pi microcontroller board. And this is a bare DEI3093 demo board. The following presentation is about how to assemble the DEI3093 and components to the demo board.
This is a DEI3093 bare PCB demo board. Its size is less than a size of a palm. This is the demo board layout. Now we are going to consider the components required for the demo board assembly.
For DEI3093 product package selection, we can use either 44 lead QFP, quad flat pack, or 44 QFN, quad flat no lead, also known as MLPQ. The user can only choose one package type to be used on the demo board. 44 QFN package type has 44 pins plus exposed pad at the bottom of the package.
Fan-out traces. If you look closer to the traces from DEI3093 footprint, you can see that almost all traces fan out to the test points along the perimeter. You can read the silkscreen labels to identify the respective pins mentioned in the datasheet of DEI3093. Connecting the test points to oscilloscope, we can study the input and output signals of the DEI3093 transceiver operation for development and programming purpose.
The DEI3093 require various capacitors to function properly. These capacitors, CVDD and CVDD1, are power coupling capacitor. Typically we use 10 microfarad and 10 nanofarad capacitors to stabilize the VDD supply voltage. These capacitors, CP and CN, are flyback capacitors. Typically capacitor values are about 2.2 microfarad. The flyback caps are used for transferring charges to the voltage doubler storage caps. CP for the positive side, and CN for the inverting or negative side. These capacitors, CV2P and CV2N, are voltage doubler storage caps. Typically capacitor values are about 10 microfarad to 47 microfarad. They hold the charges for the doubler voltage supplies at about ±5 to 6 volt. These voltage supplies are for the ARINC receivers and transmitter power. CV2P for the positive side, and CV2N for the inverting or negative side. Resistors and LED. This is the power voltage supply indicator LED. The LED will glow when power supply of 3.3 volt is present. And this is the DEI3093 operation status indicator LED. The LED will display flashing light during DEI3093 SPI operation pauses.
Look closer to the surface mount pad number of the LED. Connect LED anode to pad 1 and cathode to pad 2. The LED and resistor pairs are powered by 3.3 volt. The user may choose their current limiter resistor value and LED for the desired luminance. In this example, we use 3 kΩ resistor with a LED of 1.8 volt on voltage. These LEDs are optional components. The overall DEI3093 SPI operation will not be affected even without these LEDs. They are used as visual indicator only.
Install a 2x20 female header at the bottom of the board. This is for connection to the Raspberry Pi microcontroller board.
The DEI3093 transceiver is to be powered with 3.3 volt supply. A typical DEI3093 consume about 30 mA of current. The Raspberry Pi microcontroller board can supply 3.3 volt with limited current drive. Install a 0 ohm resistor to connect the 3.3 volt power. User may use 5 volt supply from microcontroller board with a 5 volt to 3.3 volt voltage regulator, an input capacitor. Warning: do not connect both 3.3 volt supply from regulator to 3.3 volt supply from the microcontroller. Connecting both supply will not result in high power capability, but overheating of the supplies. If the user plan on using DEI3093 to drive a high output load, consider connecting an external power supply to the 3.3 volt and ground pins here, instead of drawing power from the microcontroller board.
The DEI3093 typically use 1 MHz clock for a clock pin. We can connect a 1 MHz clock from the microcontroller by connecting a jumper wire on the jumper holes. Or we can connect an external clock with frequency of 1 to 30 MHz to the A clock pins. See the datasheet for instruction of programming of A clock input frequencies.
Receivers and transmitter connections. Each of the DEI3093 receiver or transmitter has connection options of internal resistors or external resistors. You can see that the receivers and transmitter pins are not directly connected to the perimeter test points, but connected to the adjacent jumper pinholes. We can connect wires or 40 kilo-ohm resistors to the appropriate pinholes for the internal or external resistors option.
With the right jumper options, we can loop back the transmitter output to the input of the receivers. The loopback feature is very helpful for developing program code and understanding the SPI operations. If an external connections are needed, then connect external cable to the jumper holes that are closest to the DEI3093 device on the demo board. The closest jumper holes are the ones that connected to the device's pins.
These are the components for the demo board. The screws and nuts are for simple PCB board standoff. The wire at the bottom is for connecting the receivers and transmitter jumper options. The rest of the components has been described previously.
These are the components placed at the respective location on the demo board. The following jumper options is the typically one for loopback operation. Add this jumper to provide clock signal from Raspberry Pi microcontroller. Add these jumpers to connect receivers with internal resistors option for receiving loopback ARINC signals. Add these jumpers to connect transmitter with internal resistors option for output of loopback ARINC signals.
For new development, please contact DEI sales representative for technical information. DEI can provide demo board and software for the Raspberry Pi microcontroller. Schematic, program code and SPI operation syntax example are available as reference.
Visit DEIAZ.com for more product info. Thank you.
Thank you.